Okay, so for the second part, we're talking about number of solutions. It's related to the first lesson, so it's kind of a continuation. I told you guys this entire unit, we are going to be graphing two lines. And those two lines can be graphed in three different ways. So there are three different scenarios that I want to talk about. The first one looks like the very first column or the first row. And it is when you have two lines that are intersecting. So basically you have a blue line and a red line, and they're going to meet at one point. So what we're going to do for every one of these scenarios is we're going to talk about the slopes of the lines, and we're going to talk about the intercepts of the lines. I want you guys to notice that for intersecting lines, are the slopes the same for those, or are they different? Yeah, they're going to be different. They're not going to be the same. They're going to be whatever they are. They don't even have to be perpendicular. It can literally be anything. How about the intersects, like, intercepts, like the x-intercepts? Are the x-intercepts the same or different? So take a look at the red x-intercept is here, and the blue x-intercept is here. So are they the same x-intercept or different? They're different. How about the y-intercept? So again, the blue y-intercept is here and the red y-intercept is here. Are they the same or different? Different. So the intersects are also going to be different. And when you have a scenario like this, where the slopes are different, the intercepts are different, you have only one point of intersection. There's only going to be one solution to this, one point of intersection. And you can see that I'm going to, I guess, highlight it in the yellow. It's this point right here. Oh, not that point. It's going to be this point right here where the two lines meet. Question?
Wait, in brackets for the intercept, it says like unless the lines intersect on one axis at the origin, like what does that mean?
So that means there is a little bit of a rule breaker there. Let's say you have one line like this, but then let's say you also have a red line like this. Technically, in this case, the slopes are different, the y-intercepts are different, but it just so happens that the x-intercepts are the same. So it doesn't matter. It's still going to be intersecting lines. It's still going to be one point of intersection. Another example could be, let's say you have, let me give you one other example. Let's say you have a red line meeting like this, and then you have the blue line. Imagine that they're crossing perfectly. So the slopes are different, the x-intercepts are different, but the y-intercepts are the same, but they would still be intersecting lines. So there are a couple of rule breakers to that, which I've just written in brackets. Najib? Yeah, it doesn't matter wherever they're meeting. If they're meeting at the origin, then the intersects will be the same. I keep saying intercepts. Okay, how about parallel lines? You guys know parallel lines are two lines that have the same, they have the same slope, but what about the intercepts? So take a look at the y-intercept and the x-intercept here, and the x-intercept and the y-intercept. Are the intercepts the same or are they different? Good. So when you have the same slope, but you have different intercepts, we are going to say those are parallel lines. And will parallel lines ever have a point of intersection? Will they ever meet? No. So in this case, we say there is no solution. There is no point of intersection. They will never, ever meet. Okay. And then finally, this is probably a new word. You've probably never heard this one before. Coincident. I know also it's hard to believe, but there are actually two lines there, and those two lines are just on top of one another. So basically imagine two of the exact same lines on top of one another. Are they going to have the same slope? Yeah. Are they going to have all the same intercepts? Yeah. So when the slope and the intercepts are the same, we see there are coincident lines. And here's something that's going to you're going to have to think about. How many points of intersection are there if there are two lines on top of one another? As many as you want. So we say there are an infinite amount. Infinite, remember, means like there is no end to the number, because every single point on this line, every single point of this line is a point of intersection. So you can just say infinite. Yeah.
So what is for parallel and intercept? What is this one mean? This is taken as parallel.
Yeah. Yeah. All right. So keeping this chart in mind, we're going to now answer a couple of questions. I know you're probably so sick of graphing, but you're probably getting good at it. We're going to graph these equations. We're going to figure out, are they intersecting lines? Are they coincident or are they parallel? But wait, I am going to force you to graph these lines using the x-intercept and the y-intercept. We haven't practiced doing that yet. So let's go ahead and practice using the x-intercept and the y-intercept. I'm going to just keep going as you do it just to save some time because I know we've already reviewed this. So go ahead and try it yourself, and then I will do my solution over here. Okay, hold on. I need to just... Okay, so I'm not sure where I stopped the recording, but just so I can go over the recording, we took each equation and I forced us to use x-intercept and y-intercept. So here's the math for the first equation. The x-intercept is -3/2, which I know seems confusing, but if you change it to a mixed fraction, it's just saying -1/2, 0. So you estimate where that would be, and then 0, 3. For the second equation, your x-intercept was 2, 0 and 0, -4. Did you guys get that? Yeah, okay. And then when I graph the lines, I can very clearly see that these are parallel lines. So you guys, if these are parallel lines, how many solutions are there? One, none, or infinite? Yeah. Yeah, so we're going to say parallel lines, therefore no solution. Does that make sense, you guys? Yeah, Shweta? You don't need to add any more points. Yeah.